Okay, let's look at integration by parts again. We're looking at what types of functions are being multiplied over here. We got a polynomial and we also have an exponential there. On our list, we know polynomial comes before exponential, so that's going to be our choice for u. Derivative being 2x dx. The rest of this then is our choice for dv, which would be our exponential here, e to the x dx. And the reason this is better to have on this side, that's an easy antiderivative to find. That would just be e to the x. So putting it into our integration by parts formula now, we have our selection of u times our v, which was e to the x, minus the integral of that same v times our du, which ends up being 2x dx. Okay, so this first part, really nothing we can do to simplify that. Minus, I am going to pull that constant of 2 out. But what we're left with here then, actually I'm going to keep the 2 in. What we're left with here then is a integral. We're not, even if I pulled that 2 out, we're not going to be able to simplify that integral or come up with the antiderivative of that integral, because we're still in this case where we have two functions being multiplied here. When you do that, you can't just find the antiderivative of both of these. That's not the antiderivative of this, because it involves kind of doing the opposite of product rule. And so this is going to require us actually here to do integration by parts a second time. We have an exponential and another polynomial here. So we're going to, again, have to do some integration by parts to get us to the answer we want. So the derivative is that. Our dv choice here is e to the x again, meaning our v is e to the x. So what we're going to have to do is a second time here, put in what we get for integration by parts. So we have our new u here, which would be 2x, times our new v, which is e to the x, minus the integral of that same v, e to the x, times this new du, which is 2 dx. That now we get, now that you look, you can see this integral here. We should be able to do that one. We only have one function there. That one we should be able to now simplify. So let's keep going. We got minus, and this would be 2x e to the x. Now I am going to pull that 2 out. So it's just the integral of what's e to the x dx. That one we know, that's just e to the x. So now we get this plus c. So what do we have to do? Is that our answer? Are we finished? Well, almost. We substituted all this in place of this integral up here. And notice that in front of it was a minus sign. That minus sign now needs to get carried through and everything needs to get subtracted here. So we end up with x squared e to the x minus 2x e to the x. The next one's minus a negative, so that'll turn into plus 2 e to the x. And then our constant. Now, when you're doing this constant, we don't know what the constant is. So if you want to, I mean, you can have minus e, but it's no different than putting plus e either. We still don't know what this constant is. It could be positive, negative, whatever. So you don't really need to distribute through anything to a constant. It's still some unknown constant. So that would be our answer to this one. If you were to find that derivative, you should end up with what that integral we started with once you simplify that. One note, you may see on the test the factored form of this like we've seen with some of these other problems. So don't be surprised if you saw this as a choice and you had to know that these two are equivalent to each other. All right, let's have you try one out here. See if you can pause the video and see if you can do integration by parts in this one. You will need to do it twice, kind of like the last problem, in order to get the answer. All right, let's see how you did here. So your first choice for u and v should have been over here. You got x squared is a polynomial where trig comes after, so that would be our dv. Antiderivative being negative cosine x, so you put those things in. We got our u and our v, v du. I did see that we had two negatives here, so I made that into a positive. But this is still a function now. We got two functions being multiplied. We can't find that integral easily. It requires the second time, so we got our u, our dv over here, find the antiderivatives of sine x and our derivative 2x, put those in now for u, v, and u, and simplify. And if you did it correctly, you should have got that for the solution. So that's integration by parts, where you may have to do it like a second time to come up with the answer.